Okay, so let's do in class 6, number 4. It says find the gradient of the function and the max value of the directional derivative at the given point. And our function here is sine x squared y cubed, and here's a point, 1 over pi. So by theorem 12, we know the max value of the directional derivative at any given point, so in particular our point, will equal the magnitude of the gradient at that point. Okay. So in particular, we have to find the gradient at our point and then find the magnitude to find our max value. So note, so our f(x), so derivative of this guy with respect to x, so the derivative of sine cosine of x squared y cubed times derivative of the inside with respect to x, so it'll be 2x y cubed fy. So again, here's my f. So derivative with respect to y would be cosine x squared y cubed times derivative of the inside with respect to y this time. So bring the 3 in front, 3x squared y squared. Okay, so then our gradient we can write this as 2x y cubed cosine of x squared y cubed I plus 3x squared y squared cosine of x squared y cubed j. Okay, so now we have to evaluate at our point. So then our gradient at our point, 1 over pi, this is our x, this is our y. So on the equation above, stick in 1 over pi for x, pi for y. So it's going to be 2 times 1 over pi times pi cubed times cosine of 1 over pi squared times pi cubed. That's I direction, plus plug in here, to be 3 1 over pi whole thing squared times pi squared times cosine of 1 over pi squared pi cubed j. Okay, so simplifying this with here, cross out, maybe 2 up in that one. This will cross out, maybe just 1 left there. Both those will cross out. Same thing here. So just the pi left here. Okay, so rewriting. Let's move this computer screen here. So hence, our gradient at 1 over pi becomes then 2 pi squared cosine of pi I direction plus 3 cosine of pi j direction. All right, so the cosine of pi is -1. Okay, so this become then 2, after minus 2, so bring the minus in front, so the minus 2 pi squared by minus 3j. We can bring a minus sign up front if we wanted to. That's fine. So that's our gradient. The gradient. So then the max of our directional derivative, again by theorem 12, the magnitude of our gradient. Okay, and here's the gradient up here, so it's going to be then square root negative 2 pi squared plus negative 3 squared. And that becomes then square root of 4 pi to the 4th plus 9. You can leave your answer like this. So that'll be the max value of the directional derivative at this point. Okay, so we're done.